this is Mahesh. Hope you are doing good. In this video we will learn about bubble sort. So in the previous video we learned about selection sort. So it is somewhat similar to the selection sort. So what exactly is the bubble sort? So here we are trying to push the maximum element towards the right. So that is the principal logic here. So if we consider an array here, so in this array what we are trying to do, we will take this maximum element and we will try to push it towards right until it gets its right position. Okay, so let us consider this array again. Let us try to simulate that scenario. So now we have this 21 and let us compare this with the next element. So which one is bigger? So 21 is bigger. So what I will do, I will simply swap them. So 15 comes here and 21 comes here. Now from this position again I will do the same thing. I will compare this with 7. So which one is bigger? 21 is bigger. So I will swap them. Now again here I will compare this with the next element. Which one is bigger? 21 is bigger. So what I will do, I will simply swap them. Then here 21 and 3, which is bigger? 21. So I will swap. So at the end 21 is again bigger than 5. So I will simply swap them. So now if you see, at the end of this particular iteration we pushed our maximum element towards the right. So this is why it is called bubble sort, because we are trying to bubble out the max element towards its right position. So this is at the end of the first iteration. Now we will try to see the second iteration. So now at the end we have 15, 7, 8, 3, 5 and 21. So now since this element is already in its sorted position, we don't need to repeat this process till here. So what we will do, this is unsorted and this is sorted section. So again we will start from here. So out of these two, which one is bigger? 15 is bigger, so I will swap them. So this is the first one. Next, out of these two, which one is bigger? 15 is bigger, so I will swap them. So out of 15 and 3, which one is bigger? 15 is bigger, so I will swap them. Out of these two elements, which one is bigger? 15 is bigger, so I will simply swap them. So at the end of the second iteration we get array something like this. So now at the end of the second iteration, till here the elements are sorted. So the right side is sorted and the left side is unsorted. So now the next iteration should go only till the end of the unsorted values. So now we will repeat between 7 and 8. So already 8 is the max value, so it is already on the right side, so there is no need to swap. Now between 8 and 3, so we will have to swap them. Now between 8 and 5, we will have to swap them. So at the end of this iteration we get something like this. So till here the array is sorted. We will repeat the same thing. So out of these two, 7 is bigger, so swap. Out of these two, 7 is bigger, so swap. So now at the end of this iteration we get something like this. So now till here the array is sorted, it is unsorted. Now what we need to do, we need to repeat this process till this element. So we will simply check. So they are already in their sorted position. So at the end of all the iteration we finally get the sorted values. So let us try to look it in pseudocode. So what we did, we started from the last position and then we kept on moving towards the first position. So for that let us consider bubble sort method takes an argument which is a, which is array of numbers. Then what I did, I started from the last element, which is, if it is starting from 0, then this will be my n minus 1th element. So then it moves towards the left and it stops when it reaches 0. So n minus 1 to 1. This is the first iteration, so we will use the same. So for I equal to n minus 1, I greater than 0, I minus minus. Here it is not greater than or equal to 0 because we are not repeating it for the 0th index. We will stop once the first index gets over. So next loop. So after starting here, what we normally do, we will try to shift the element from its position towards right. So this happens from 0th index till the n minus 2nd index. So this n minus 2nd means, so for the first iteration it is n minus 2, but for the second iteration it goes till n minus 3. So one index before the last sorted value. That's why j equal to 0, j less than n minus, sorry, j less than I and j plus this. So here I will check if a of j, if it is greater than a of j plus 1. So because we will compare these two elements, if I am starting from this location, I'll compare it with the immediate next element. If that is the case, what I will do, I will swap a of j with a of j plus 1. So at the end of the first iteration, our max element moves at the ith position, which is n minus 1 for the initial iteration, and which gets decreased. So at the end of both the for loops, we get the sorted array. So let us see what is the time complexity for this one. So time complexity. So on the naked eye, I mean, we can see that there are two for loops. So basically it is of order n square. But let us see that in action. So when I is n minus 1, basically, so this iterates till n minus 2. When I is n minus 2, it executes for n minus 3. When I is n minus 3, it executes for n minus 4. Likewise, when we reach 1, this executes almost for 0 times. So when it was 2, it will be 1. So if we sum up this, it is somewhere n minus 2 plus n minus 3 and so on till 2 plus 1 plus 0, something like this. So let us assume it is n. So it is starting from n, then n minus 1, then n minus 2 for convenience. So basically this is sum of n natural numbers. So which will be n into n plus 1 divided by 2, that is equal to n square plus n divided by 2. So we consider highest degree polynomial term. So that is why it is of order n square. It is of order n square. And what is the space complexity? So here we are not using any extra space. It is a in-place sorting algorithm. That's why it is of order 1. It is of order 1. So this is basically the pseudocode. So now if we see this pseudocode, it almost executes for every iteration for each term. So for placing the max element at this position, it will iterate throughout this all the elements and then it will shift. So it does for each and every element. So that's why it is of order n square. Is there any way we can improve? Let us see a small example here. Let us assume the array is already sorted. 1, 2, 3, 4, 5, something like this. Okay. So let us try to push the elements, compare these two. So they are already this element is smaller than the next element. Now compare these two. So this element is less than this element. We don't do any swapping. This element is less than this element, so we don't do any swapping. So this element is less than the next element, then we don't do any swapping. So basically what we have to understand here is, once the elements are already in their sorted order, that time we don't get any swappings. So what we can do, we can keep a flag here, say for example flag equal to false, which indicates whether any swaps happened or no. So after swapping, we will simply set flag is equal to true. Now at the end of the second loop, we will check if flag is equivalent to false, then we will simply break the loop. Why? Because once we get to know that all the elements are sorted, we don't need to further try to sort them. That's why after checking this particular flag, if there are no swaps happened, then we simply break the loop. So this is an improvement. So if we do that, then the best case time complexity is of order n, because once the elements are already in their sorted order, we don't really need to swap, or we don't really need to compare after the first iteration. So that's why the best case time complexity is of order n, and average time complexity and worst case time complexity is of order n square. So that is all about the pseudo code for this bubble sort. Let's look this bubble sort in program. Create a class in this sorting folder. So let it be bubble sort dot java. This is the class. Now let us create a static void method. Then after that, let us create a static method which returns us array, the sorted array. We will call it as sort, and it accepts array of integers, and it is basically a. Now let us declare a variable int n which holds the length of array. Now let us create a for loop int I equal to n minus 1, I greater than 0, I minus minus. One more for loop, basically int j equal to 0, j less than I, j plus plus. Now I will check if a of j is greater than a of j plus 1. Then what I will do, sorry, there is a square bracket issue. What I will do, I will swap a of j and a of j plus 1. So int temp, let's do the swapping. Int temp equal to a of j equal to a of j plus 1, a of j plus 1 1 is replaced with temp value. So this way we swap the values, and once everything is done, simply return A. Now in the main method, let us create a variable A which holds the array of integer numbers, and let's pass 21, 15, 7, 8, 3 and 5. These are the values we used in pseudocode. And now let's call sort method and assign it back to array A. And once after this, let us try to print the sorted array. So for that I will use again for loop for int num of A. I will use system dot out print method. So I will print num, and after this I will print a comma and a space for better readability. And once everything is done, I will save the changes, and this is done. I will run the code. So here we go, we get all the sorted numbers 3, 5, 7, 8, 15 and 21. So this is basically it tries to sort all the elements, so it really does not bother whether the elements are already sorted or no. So for that, as we discussed, so let us create a boolean flag which is equal to maybe true initially, or maybe let's put it false, and if any swapping happens, then only what we will do, we will set it to true. So we will check at the end of the second for loop, we will check whether this flag is set. If this flag is equal to false, then we get to know that there are no swappings happened, so it means it is already a sorted array, and we will simply break from the loop instead of proceeding. So now once this is done, let's simply run and see if things work fine. Yeah, everything is working fine. Let us take a different example, maybe 1, 2, 3, 4 and 5. So this is already a sorted array, so let us try to run for this input. So now we can see this sorted value, but how to get to know that, I mean, it is not entering into this continuous loop. So for that, what we will do, we will simply put a system dot out dot println, and we will put simple output saying swapping. So if I run it, so there are no swaps happening, that's why it is not entering inside the swapping. So let us see one in action. So I will simply change. So this will basically, what it does, it will swap once these two elements. Other elements are already sorted, so it should print at least once, not at least, it should print once this particular statement. So now with that, let's run. Yeah, there is one swapping string which is outputted on the console. Yeah, that's it for this video. Thanks for watching the video.